This week we have talked about a new kind of motion called harmonic motion. And you might also see it called simple harmonic motion sometimes. And the simple usually just means we have one frequency component. We have one sinusoid. You can actually build up almost any motion by adding up different sinusoids. It's called Fourier series. But for now, we have one. Therefore, we could attach the word simple on there. And what I think is interesting is this illustrates why Newton's laws, basic ideas like Newton's laws and conservation of energy are so powerful, is because they describe many different physical situations. So if we just think about your basic F equals ma. So we started out and it successfully described trajectories when we had a constant force. And then all we had to do was take that constant force and turn it at 90 degrees, and then it describes circular motion. Completely different motion. But we describe it by saying the acceleration is in v squared over r. The force you need to make circular motion, mv squared over r. It's directly from Newton's second law. Let's see. It also described the case where this is the sun, right, and this is a planet, and it describes an orbit. So if you go into gravitational forces, you got to apply it as circular motion, and you get gravitation, and you get orbits. But then the wildly new thing it described this week was harmonic motion, and it was not that we came up with a new F equals ma. It was just it applies to yet another situation. Any force you put in here will create an equation between the force and the position of the velocity and acceleration, and if you solve it, it can describe any motion. And there are others. We could go on and on. And this is the idea in physics. Some equations are very general and always apply. Another one we've applied to all these situations is the conservation of energy. It is that for a mechanical system at least, K plus U is constant. And if you want to bring in more energy, we can. Friction, internal energy, you bring in chemical energy, etc. Right now we're trying to keep it simple for this class, just mechanical energy, K plus U. But again, this idea applies to trajectories, it applies circular motion, it applies harmonic motion. So in physics, we're always looking for these simple ideas, simple equations that basically apply to everything.